when understanding how muscles make bones move. So the origin of a muscle and the insertion of a muscle, each muscle essentially, maybe let me try to sketch, each end of a skeletal muscle has, kind of draw a little skeletal muscle with some tendons down here, like that. There's some tendons up here, and it's going to be attached on one end to one bone and on the other end to another bone. So if we had a muscle that was kind of attached to a bone and then the other end of the same muscle that was attached to the bone, like that, then when this muscle contracts like that, the two bones will move together. Okay, but typically one of the two bones stays in place. It doesn't really move. It's more anchored. So we might have a bone, like if I could sort of draw the humerus like this, and the ulna like this, and then out here somewhere is your hand. Those are your fingers. This is the ulna. This is the humerus. Okay, and then the muscle itself that we'd be talking about comes from sort of either somewhere up on the humerus and attaches down to the ulna like that. And when the muscle contracts, it tends to make one of the one of the bones move, and the other one stays in place. So this end up here, that's more of the anchor point that does not move, is considered the end that's called the origin of the muscle. Both of these words refer to ends of the muscle. So the origin of the muscle is the end that's more anchored, or less movable, as we describe it in the lecture notes. And the other end that really does most of the moving is called the insertion. Okay, so essentially all skeletal muscles have kind of an origin and an insertion, an anchor point and a movable point. So let's kind of draw a little anchor like that. There's our little anchor. That's the origin, the anchor point, and then the insertion is the end of the muscle that pulls the moving bone closer to the origin when it contracts. All right? So when it comes to learning all these muscles for lecture, now there's a lot of movements and stick figures and stuff like that, and those are fun, but I don't think we really have time to go through all of those, and I'll be clear, you don't have to know how to do these for the test. But I do want to kind of say this, that this is mostly, what I'm about to say is mostly but not completely true. And I passed this along from my friend Ms. Long, who taught me a little bit about how to teach this a little bit better, that most of the muscles on the front of your body, front is not an anatomy word, it's anterior or ventral, but most of the muscles on the front are flexors of some kind. This is not really true of like the facial muscles, and the big exception is the muscles of the thigh, because the muscles on the front of your thigh are actually extensors. But for the most part, most of the muscles on the front of your body are flexor muscles. They cause flexion. Okay, so what is flexion? Flexion is decreasing the angle of a joint when it's in anatomical position. Okay, so the example that I've got over here of my humerus and my ulna, where when this muscle, like brachialis or biceps brachii on the front of your humerus, the front of the arm, when that muscle contracts, it pulls the ulna up. That's called flexion. When your arm is in anatomical position down at your side, And then when you curl your elbow, like you're bending it up, to bring some food to your mouth or take a drink of something, that's flexing the elbow. The opposite of flexion is extension. So we talk about extension going back to anatomical position. We talked about these these movements a few weeks ago when we went through articulations. Okay? So most of the muscles on the front of the body, really from the neck, starting from the neck down, mostly flex. So there's a muscle on the front of your shoulder that flexes your shoulder. It's part of the deltoid, and pectoralis major also does that. Muscles on the front of your neck flex your neck. Abdominal muscles on the front flex your torso. Muscles on the front of your arm flex your forearm. Muscles on the anterior of your forearm flex your wrist and fingers. Muscles on the back are the extensors. So extending your wrist and extending your fingers are muscles that are on the back of the arm and the forearm. So this is a general overall plan that if you get in a situation on the test where there's a question that you just can't really remember, then maybe this can help you narrow it down a little bit. Okay? The big exception is because the knee actually bends the opposite way from your elbow and your wrist and your ankle and your hip. The knee bends the other direction. So I'm going to do a stick figure down here too. You got like this, and here's a stick figure kind of bending their elbow. That's flexion. But if this same stick figure flexes the knee, flexion of the knee is actually done by muscles on the back of the thigh, not the front of the thigh. So that's why the thigh muscles are an exception. Flexion of the knee is muscles on the back of the thigh, the posterior thigh, not the front. Muscles on the front of the thigh are extensors. Muscles on the front of the thigh will actually extend the knee back down to anatomical position to straighten it back up. Okay? So with that in mind, let's just take whatever time we have left and go through these sets of muscles. Answer any questions you have about them. Excuse me. Try to do some blank filling in and give you guys some good concepts to build on. So starting on page 123, the muscles of the head and neck, this kind of takes up a little bit of that first whole page, but it's, again, not a lot of muscles. It is, honestly, I think it's nothing compared to the amount of muscles that you need to know for lab. You got to know a lot more muscles for lab. But I'll give you some clue words there under facial muscles. The word oris means mouth, and oculi means eye. And so orbicularis oris, that word literally means around the mouth. It comes from the same root word as orbit, like goes around. Orbicularis is a muscle that goes around the mouth, and orbicularis oculi is a muscle that goes around the eyes. So the facial expression produced by each of those muscles, I mean, it's a lot of muscles, but like I said, it's nothing close to what you're learning in lab. But orbicularis oris basically puckers your lips or helps close the mouth, purse the lips really tightly. And orbicularis oculi does the same things with your eyes. It helps you squint your eyes and close your eyes very tightly. Buccinator and zygomatic are a couple of different muscles. The buccinator is in your cheek. In fact, the word buccinator comes from the word for the cheek cavity, the buccal, B-U-C-C, that doesn't look like a U, B-U-C-C-A-L, the buccal cavity, which is that space just inside your cheeks, between your cheeks and your teeth. That space is called the buccal cavity. And the muscle that's in the wall of your cheeks comes from that Latin word for cheeks. It's called the buccinator, and it actually is a chewing muscle. It's for mastication. It's one of the muscles of mastication. And the zygomatic muscle is one of many muscles. There's actually two zygomatics on either side, called zygomaticus major, zygomaticus minor. You're probably looking at those in lab, maybe this week, maybe next week. I can't remember in A&P 1 when you guys study the muscles of facial expression. But the zygomatic muscle is your smile muscle. It pulls the corners of your mouth up, so it kind of helps you to smile. It kind of inserts on the corners of your mouth and helps to pull the corners of the mouth up into a nice smile. Muscles of the face insert into the skin. They're innervated by the facial nerve. How many facial nerves are there? Well, two. There are a lot of branches, but there are two facial nerves. The muscle that allows you to smile is zygomatic, and paralysis of the facial muscles on one side of the face is sometimes referred to as Bell's palsy. Bell's palsy, but Bell's is actually one of many conditions that we now recognize fall under the category of what's referred to as facial nerve paralysis. So you don't need to memorize this for your test, but if you're going into nursing, you'll need to learn that Bell's palsy is one of many different things. Skin, inserts into skin. They're the only muscles in the body. Sternocleidomastoid. Contraction of both sternum. Now, sternocleidomastoid is an interesting muscle because it's got its origins and insertions right there in its name. It originates on the sternum and the cleido. Where's your cleido? Cleido is actually a German word for what body part? What bone? Clavicle. Yeah. It's the German word for the clavicle. So sternocleido is the origin of the muscle. Mastoid process right behind your ear is the insertion. So these are the muscles that kind of do your face here like this and your neck like this. So these are the muscles that originate kind of on your sternum and go up the side of your neck. And if one of them contracts, it can cause your head to turn in the opposite direction. But if they both contract, they kind of cause your neck to sort of tilt downwards. Both of them together. Yeah, they sort of flex the neck. What would happen if the left sternocleidomastoid muscle was contracted but not the right? That would turn your head opposite of the muscle that is contracting. What would happen if the sternocleidomastoid on the left contracted? It would turn your head in the opposite direction of the muscle that's contracting. So it would turn it to the right. And that, in fact, is how you turn your head to the right. If this is the picture that you're looking at, this is their left. And if only the left one contracts, the muscle there, that will turn their head towards the right in that direction. The scalene muscles are deep under here. They can also cause neck flexion. There's actually 3 layers of scalene muscles. But they also have the ability to kind of raise the rib cage. They kind of insert on the top of the ribs. So if you can try this at home right now. I want you, in just a second, I want you to just take a rapid, deep breath. Just inhale real deeply, but I want you to pay attention to how you can feel that in your neck. Okay, go. You feel that? Some of you are like, I'm not doing this. Okay. You guys that are not playing along, you were like me when I was in school. I was like, I'm not going to play your silly game. But if you take a deep breath, inhale very quickly, you can actually feel muscles deep in your neck. And those are your scalenes that are helping pull up on your ribs. They're kind of helping to pull up on your ribs. So this says this right down here in our notes. The scalene muscles can cause neck flexion. On the other hand, if you hold the head still, they can lift the rib cage to assist in breathing, mostly during inhalation or inspiration. trapezius on the back of your neck. So the trapezius are these two big muscles. Here we go. Kind of draw the back of somebody's head over here. This is them from the back. It's going to make it an old man with bald head on top. Little old man ears. Saggy little old man ears. But if you look at your neck, you'll typically see kind of these two columns of muscle on the back of the neck. Those are the trapezius muscles, your left and right trapezius muscles. And they extend the neck. So these are the major muscles that tilt your head back and allow you to kind of look up at the ceiling or look up at the sky. Those are the primary ones there. Okay. Then on the next page, we got pectoralis major. Every high school boy, I think, is pretty familiar with those because those are the ones that you do push-ups for. But these are the big chest muscles. There's another one deep to those called pectoralis minor, but pectoralis major muscle does a lot of work on the shoulder. See, it's got 3 blanks. What are the 3 things pectoralis muscle does to the shoulder? Flexion. Yep, it does flexion. What else does it do? It does adduction, and then it does what kind of rotation? Medial rotation. Yeah, medially rotates the shoulder. Okay, so I don't know. Can you guys? Let me turn the camera on. I turn my camera back on and hope that my internet connection works okay. If you click on my picture down there, it can make it a little bit easier because I want to show you what this means if I turn myself sideways like this. Here's my shoulder. So I hope you can see it. Flexion of the shoulder would be like extending my arm straight out in front of me from anatomical position. Flexion of the shoulder, you can't see. You don't see nothing. Am I doing something wrong? You see? My camera is on. Is it just like a tiny little screen down? Can you click on me and make me bigger? I may have to be tiny. Let's see if I can. What about that? Whoa. How about that? There's no way you don't see me now. There's no way. It's like I'm looking in the mirror. I know. I don't know. I don't know if I'm actually that large in real life, though. All right, here we go. So, shoulder, anatomical position. This is called flexion. That's called flexion of the shoulder. Now I'm going to swing it around and look what it looks like. That's flexion of the shoulder, right? Oh man, put on your 3D glasses. This will be really cool. Whoa, like that. That's flexion of your shoulder. That's pectoralis major in part. Okay. What else does it do? Adduction. So I'm going to stay facing forward. If I put my arm out like this, my shoulder is abducted, abducted, like that. Pectoralis major in the chest pulls it back down to anatomical position. That's called adduction. Okay? It also rotates the humerus towards the middle. The front part turned towards the middle. Okay? Use something maybe that shows up. If we put like a marker on the front of the humerus, like this, and then I flex the pectoralis major, that's called medial rotation. And the relative point is the front of the humerus. Okay? I'm going to leave that up there until I need to draw on the board because I prefer to, do this with my actual body parts. Latissimus dorsi and teres major. These are on the back. I can't show you these because they're on my back. But latissimus dorsi helps to extend the shoulder. Well, latissimus dorsi is actually pretty much almost the opposite of pectoralis major, but it does one thing the same as pectoralis major. So latissimus dorsi will do this to your shoulder. like that, okay? So if this was flexion, like this, that is extension. So latissimus dorsi does extension. It also adducts, so it does two major things, like pectoralis major. It adducts and also does medial rotation of the shoulder. So this could be a good test question. Pectoralis major and latissimus dorsi do most of the same things except which one? Pectoralis major flexes the shoulder, which was this. Pectoralis minor extends the shoulder, which is that. Okay. Yeah. I didn't write that one because it just sort of occurred to me that would be a good question. I wonder who wrote that question, because whoever did was smart. Let's see, rotator cuff. The rotator cuff involves rotating the shoulder. It's called a cuff because the cuff sort of surrounds the shoulder and stabilizes the shoulder. And it involves what are called the sits muscles. Sits, S-I-T-S. Do you see how they're listed under number 3 at the bottom, page 124? Supraspinatus, infraspinatus, teres minor, subscapularis. They are not written in that order by accident. S-I-T-S. Those 4 muscles, the sits muscles, are the rotator cuff. Okay? Now, only one of those medially rotates the shoulder. It's the subscapularis. The other 3, the other SIT, supraspinatus, infraspinatus, teres minor, they laterally rotate the shoulder. But you can see how the supraspinatus, infraspinatus, teres minor, lateral rotation of the shoulder, they help to balance the subscapularis and pectoralis major and latissimus dorsi, which at the top of the page we said medially rotate. Okay, so kind of put all these things together in your mind. Make matching sets. What are the muscles that medially rotate the shoulder? Pec major, latissimus dorsi, teres major at the top, and subscapularis towards the bottom of the page. What muscles laterally rotate? Sit of the sits. The SIT of the sits. Okay? All right. And then good question here, good terms to know here at the bottom that we talk about more at the latter part of the chapter, synergists and antagonists. Synergists are muscles that work together. Antagonists are muscles that do the opposite. Antagonist in this case is not bad, but they do the opposite. All right? So, pectoralis major medially rotates. That means it is a synergist with latissimus dorsi, teres major, and subscapularis that also medially rotate. Right? It's at the end of the chapter. They're just bold-faced terms, definitions at the end. I'm sure. I can't remember. Okay? Does that make sense? Okay? So put all these pieces together. Put all these pieces together as you go through it. This is the advantage, guys. Look. Listen. I can't do all of it for you. This is the advantage of doing that table on page 129. When you do the table on page 129, you kind of go, oh, I see how all these muscles work together. You're going to have a bunch of muscles that are in that synergist column for something like, where's rotation of the shoulder? Oh, okay. Maybe that's not one you need to know too much about. Yeah. Okay. So once again, I've over-explained it. I've overdone it. All right, let's get back on track. Deltoid muscle. Major function of the entire muscle of the shoulder is this. What was that? What did I just do? Now that I'm huge on everybody's screen, I'm going to lower it back down. Anatomical position, abduction. I know, it's hard to say. My anatomy professor, when he was teaching this stuff, Dr. Freeman, my college anatomy professor, he would say, yeah, abduction, adduction, these things are really hard. They sound exactly the same. Whoever came up with that obviously never had to say these words out loud to students in the classroom, because when you do, they sound exactly the same. He said, so I'll say abduction and adduction. And I'm like, wait, those sound the same too. Abduction and adduction also kind of sound the same. That does not help me. It does if you write them. All right, so abduction, abduction is the major job of the deltoid. It's the prime mover for abduction. In fact, the answer to that question is right at the top of page 125. It's kind of like, oh, here's a fill-in-the-blank question, and the answer is right there at the top of page 125. But this muscle also flexes and extends the shoulder too. So it does abduction, but also it helps. It's not the prime mover of shoulder flexion and shoulder extension. So it's a synergist. It helps with those other muscles that are the prime movers. And it says, how can it be that this one muscle flexes the shoulder and extends the shoulder as well as abducts the shoulder? Well, it does abduction if the whole deltoid contracts. Okay? Your brain has the ability, I'm not going to get into the nerves right now, it's called the axillary nerve. It has branches to the front and the back that are separate. So your brain, the answer to the question at the bottom of 124, is your brain can control just the front part of the deltoid, or just the back part of the deltoid, or the whole deltoid at one time. So you actually can use different parts of the deltoid at different times, if that kind of makes sense. Okay. Oh. Name a rotator cuff muscle that's synergistic to the deltoid regarding shoulder abduction. I know. Anybody know? I should say that I know before I give you a chance to answer. What is one of the rotator cuff muscles? Those are the sits muscles. Which one of those can also do shoulder abduction with the deltoid, working together with the deltoid? Supraspinatus. I agree. Supraspinatus. That's what I was taught. That's what I believe. Supraspinatus. Now, muscles on the anterior arm, on the front of the arm. The arm is just the shoulder to elbow. So there's two muscles on the front that we want you to know. There's more than that. There's coracobrachialis as well. But two that we want you to know for lecture. Biceps brachii is the prime mover. Now, again, this movement that I'm showing you is flexion. These two muscles, biceps brachii and brachialis, both do flexion. They both do it. But the prime mover for it is biceps brachii. So the major function of biceps brachii is elbow flexion. It has a couple of other tricks up its sleeve, but you don't need to worry about those. Brachialis is actually the prime mover for, we've got brachialis listed as the prime mover for elbow flexion. I think that's what's supposed to go in that blank. Yeah, let's go with it. Yeah, brachialis is the prime mover for elbow flexion. Okay. Yeah, that's not the way I usually teach it. Not here in my other anatomy class here at UGA. I usually teach it that they're kind of equal, but that's fine. We'll go with it. We're gonna get this question right on the test, no matter what. Brachialis, prime mover for elbow flexion. That makes biceps brachii the synergist, the helper. But like I said, biceps brachii has a few tricks up its sleeve. On the back side of the arm is triceps brachii, and this is the muscle that extends the elbow. And the long head helps also to extend the shoulder as well. So it has elbow extension as well as shoulder extension too. Okay. It's an antagonist of the brachialis muscle at the elbow because it does the opposite of flexion. It does the opposite of that muscle. Okay. All right, let's move along. Make sure we got time. Muscle to move the trunk, rectus abdominis, external oblique, internal oblique, transversus abdominis. So rectus abdominis on the front of the abdomen primarily does flexion of the torso, or I guess flexion of the spinal column. Rectus abdominis would be the major one that would answer that first question. Compressing the abdomen would be really the other three: external oblique, internal oblique, and transversus abdominis. And it says, why is that important? That's a good question. Why is that important to be able to compress your abdomen like that? Whew, I wish I knew. Whew, that one's a hard one. Yeah, so when you have to breathe out forcefully, relaxed breathing, like just breathing quietly, is mostly a passive process. But if you have to blow out candles on a birthday cake, or scream at your children, or whatever, sneeze, cough, you do need to contract the muscles of the abdomen. Those other three muscles, the other three, not rectus. You'll do rectus a little bit too, actually. But the external, internal, and transversus all kind of squeeze your abdomen like squeezing the middle of a tube of toothpaste, kind of. And it pushes your liver and stomach up against the underside of your diaphragm, which helps force air out of your lungs. So I would say, why is that important? I would say during expiration specifically, not just breathing, but when you're blowing air out. And I would go ahead and put that word, because that's a word you're going to have to learn in A&P2 anyway, so why not go ahead and put that one in here. Which muscle is the most superficial? Well, the external. That's why it's called external. Which is located deep? Which muscle is located deep to the others? Transversus abdominis, transverse abdominis. The erector spinae muscles, erector spinae muscles is how that's pronounced in Latin, but most people say spinae. Erector spinae muscles, a lot of muscles in your lower back, and they will extend the trunk. They'll kind of, back like this, stretching back like that. Diaphragm, your major muscle of breathing. It is also a skeletal muscle. Muscles that help the hip and leg. The iliopsoas is how you pronounce that one. Iliopsoas is your major hip flexor. It's your major hip flexor, prime movement. All right, I'm going to have to get up now. Here we go. All right, prime mover of hip flexion. So here's my hip. There we go. There's the thigh right there. So hip flexion would be like that. Okay? So everybody can see that I didn't dress up for class today. I feel so unprofessional. Okay? So this is anatomical position. And then hip flexion, that's mostly muscles deep in the pelvis and your lower back. But you guys don't have to be on camera. Yeah, my wife dresses me in pink. Thank you for pointing that out. She turned me into a prep. So that's hip flexion. That's mostly iliopsoas. It's composed of two muscles called iliacus and psoas major. Well, while I'm here, let me talk about quadriceps down there too. So quadriceps muscle, why is it called quadriceps? Well, there's four of them: rectus femoris, vastus lateralis, vastus medialis, and vastus intermedius. And all four of them are located on the front of your thigh, and their job is to extend the knee. So this is the knee when it's kind of flexed, and these muscles on the anterior thigh actually extend the knee like that. They extend the knee out like that. Okay? That's why I wore shorts, so I could show, the muscles of the knee. So they extend the knee. But these are the muscles that are the exception to what I was telling you. Most of the front of the body are flexors. Flexors of the elbow, flexors of the wrist, flexors of the fingers. They're all on the front. Flexors of the torso, all on the front. Flexors of the hip, mostly kind of on the front. The big exception, front of the thigh, not flexors. Front of the thigh, extensors, and those are the quadriceps, because there's four parts to that muscle. Which quadriceps spans two joints? Rectus femoris. Which of these muscles causes hip flexion? Rectus, because it spans the hip and the knee. Which muscles cause knee extension? All four. Which nerve innervates these muscles? Anybody got that one? Anybody look that one up? What's the name of the nerve that innervates those muscles on the front of the thigh? Yeah, femoral. The reason why it's important to know that at this point, you're going to see that word a lot. It's just the Latin word for the thigh region. The Latin word for the thigh is the femoral region. So the nerve in the front of for the muscles in front of the thighs, the femoral nerve. All right, let's hurry along. Rexiformis, blah, 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 blah. Okay. If I skip something, I'm sorry. I know that you can get what you need from the videos. I want to try to make sure that we kind of get through all the groups very quickly and make sure we have kind of time to get through everything, at least superficially one time. And then if you got questions, I can answer them. Other thigh muscles that are either on the front or the sides of the thigh. There's also the sartorius. I'll stand up again. Here we go. So sartorius is really cool. It kind of starts right out here on the hip. This, if you remember the bones of the hip that are called the iliac bone, the ischium, and the pubis, they're the bones of the hip. And on the front of the ilium is this anterior superior iliac spine called ASIS. And it's an attachment point for this sartorius way up here. And sartorius crosses all the way down to the medial side of the thigh. So it actually forms this almost S shape. And when it contracts, it actually helps it flexes the hip and the knee. So you use the sartorius when you're like crossing your leg. So like if you're going to go like this and cross your leg like that, you're going to actually flex your hip and flex the knee as well at the same time. So it's a really interesting muscle that can kind of do double duty, so to speak. It can kind of flexion of two different joints at the same time. Gracilis is on the medial side of the thigh, and it's an adductor. It helps to pull the thigh back into anatomical position. Tensor fascia latae is on the lateral side, about where you put your hands in your pockets on the side. It's a really tiny little muscle that a lot of people call an abductor of the hip because of its location. It really kind of stabilizes a lateral fascia on the side. That's where its name comes from. It's a tensor of that lateral fascia. But mostly these muscles listed down below, the gluteus maximus, gluteus medius really, are the abductors of the thigh. So tensor fascia latae actually just attaches to this band on the side of your thigh called the iliotibial tract. Running out of this. Sorry, guys. Got a bit of a mess in the laundry room. So over here on the side of your thigh, I can't really see it on me, but going right down here into the knee is this band of connective tissue between the anterior thigh and the posterior thigh called the iliotibial tract, and that little tensor fascia latae right over here kind of inserts right into it, right there on that side there. And so that's called the iliotibial tract, or the IT tract for short. And then around the backside, gluteus maximus is a major extensor of the hip. The gluteus medius is the major abductor of the hip. The gluteus medius is the big abductor of the hip. Which one laterally rotates the hip? Pretty sure that's gluteus maximus also. Prime mover for hip extension, gluteus maximus. Yeah, does that agree with what you guys found? Did I create any confusion of that? Which one abducts? Medius. Laterally rotates and prime mover for hip extension, maximus. Okay. Always reminds me of that horse in that Disney movie, Tangled. Wasn't his name Maximus? I don't know. The kids went through that Tangled phase. Hamstrings. Hamstrings. So the hamstrings are muscles in the back of the thigh. Semimembranosus, tendinosus are kind of more on the medial back of the thigh. And then biceps femoris is more on the lateral back of the thigh. I am not going to show you those because I don't want anybody taking screenshots and getting me in trouble. But these muscles, do these muscles have the same functions regarding flexion, extension at the hip and the knee? For the most part. Yeah, for the most part, the hamstrings flex the knee and extend the hip. Biceps femoris is more on the lateral back. All three of them are on the back, but the two semis are more on the medial side, and the biceps femoris is more on the lateral side. And all three of them, yeah. I don't think you really have to know. Oh yeah, you do. Look, that question down. Which muscle is located on the lateral side of the leg? Biceps femoris. Hamstrings. Hamstrings flex the knee and extend the hip. Yeah. Hold on. I'll get back to the shoulder in a sec. Regarding hip flexion and extension, the hamstrings and the rectus femoris. Well, hip flexion extension, the hamstrings and the rectus femoris are basically synergists regarding extension of the hip. Semimembranosus, semitendinosus are synergistic in their action at the knee joint. Yes, synergists. Calf muscles, triceps surae. The word surae means of the calf, means in the calf region. And this consists of three muscle parts. The gastrocnemius actually has two divisions. They're the big calf muscles that everybody that works out likes to get those calf muscles that stick out. It's the gastrocnemius actually kind of has these two parts side by side. And then deep to it, under it, is soleus, closer to the back of your tibia. And both of these muscles cause movement at the knee and the ankle. Actually, do both of these muscles cause movement at the knee and the ankle? No, I think we'd say the gastrocnemius does assist in flexion of the knee and plantar flexion of the ankle. So, yeah, that's at the top of the next page. Gastrocnemius flexes the knee. It's just a synergist. It's not the main mover of knee flexion. Gastrocnemius flexes the knee and plantar flexes the ankle. Remember, plantar flexion of the ankle is pushing your tippy toes. Getting a workout today, guys. Anatomical position, pushing your toe. I'm not even wearing shoes. I'm so relaxed, I'm not even wearing shoes. I did that, you guys, just so I could help you with these muscle movements today. So plantar flexion is pointing your toes out, like going up on tippy toes to reach something high up in the cabinets. You know, that's plantar flexion. And that's gastrocnemius and soleus does that. So both of these muscles form what's the name of that tendon that inserts into what bone there at the top of 127? Both these muscles, gastrocnemius and soleus, both form the what tendon? And it has a nickname that I think is probably okay to know, but I'd like you to know the anatomical name too. Thank you for the zero judgment. Appreciate that. Yeah, the nickname is the Achilles tendon. The nickname is the Achilles tendon, which is okay, but I would like for you guys to also know that is referred to as the calcaneal tendon. I just put it in the chat. The calcaneal tendon, because it inserts into what bone? Which is the second part of that little fill in the blank.
Calcaneal.
What bone does it do these insert to? The heel bone, calcaneus. Yeah. So that's why the official anatomy name for that tendon at the back of your heel is the calcaneal tendon. But like I said, it's okay if you call it the Achilles tendon. Make sure you capitalize it, because I don't know. why it's important to capitalize that one, because he was a mythical figure. I don't know if Achilles was a person that ever actually lived. But anyway, around on the front of the tibia is tibialis anterior, and tibialis anterior does the opposite. It's the antagonist of the triceps surae of the gastrocnemius and soleus. So if gastrocnemius and soleus plantarflex the foot, tibialis anterior dorsiflexes the foot, kind of rocks your heels back. Yeah, dorsiflexion, exactly. It will dorsiflex the ankle. Okay, that's the muscle. When you pull that muscle, it hurts the front of your shins really bad, and we call those shin splints. If you've ever had that happen, very, very painful. It can be very painful because that tibialis anterior also kind of has a tendon that attaches all along the length of the tibia. Very, very painful. So tibialis anterior is your shin splint muscle. Okay. So group action, here's that set of terms. Prime mover is the major muscle that does a particular action. Synergists assist that prime mover. Antagonists oppose the prime mover. So we would say the prime mover of flexion of the elbow is brachialis. The antagonist is the antagonist is triceps brachii. A synergist is biceps brachii of flexion at the elbow. Okay. And then somebody wanted me to circle back around to the shoulder muscles again. What was the question about this? See, the muscle of the rotator cuff. Which muscle of the rotator cuff medially rotates? Which muscle of the rotator cuff medially rotates? Somebody tell me if you got it in your notes. Let's check and see if I said it too fast that nobody got it. Which muscle of the rotator cuff medially rotates? Page 124. Kind of middle bottom of page 124. Subscap, yeah, the subscapularis. It medially rotates. The other three of the rotator cuff laterally rotate. The other three, the supraspinatus, infraspinatus, and teres minor, they laterally rotate. Okay? So connect them back up at the top with, let's see, the muscle of the rotator cuff that medially rotates the shoulder. Remember that it works together as a synergist with pectoralis major, latissimus dorsi up there at the top. So you could say that subscapularis is a synergist in medially rotating the shoulder with pectoralis major and latissimus dorsi. Okay. Jensen, go ahead. Done. Feel free to ask questions, guys.
Do you think you could go over the facial muscles again?
I could try. Now that I got myself on the big screen here, let me show you. Orbicularis oculi. Okay. Orbicularis oculi is all the way around eyes, forms an orbit around your eyes, and it helps you to tightly squint. Not just really close